Hi, in this video we are going to perform the analysis of simple regression model, multiple regression model and detection of multicollinearity along with some basic path analysis. So in order to perform all these three type of analysis, we'll be requiring some libraries like metan, like corrplot, like cars. So in order to perform all these analysis, we will recall all these libraries. Simply we'll highlight all these libraries, all libraries, and click on this run option. Then the first basic analysis that I'll be carrying out utilizing a data set which is already imported on my R console. It has got two variables, and this data pertains to the data on height and diameter of hunter pine trees. So both these two are important dendrometric variables. So I will be utilizing first this. So in order to see the basic structure of my data set, we always used to carry out the, or we used to apply a basic function in R, that is summary function, summary followed by the name of this data set. If we click on this enter, we get the results. We get the values of our minimum, maximum, median, and mean also. But we want more information regarding the descriptive statistics of our data, where center of gravity should also be displayed along with the spread, along with the dispersion. For that we will use a function that is known as stat.desc followed by the name of this data set, that is pine. Here you can see apart from the total number of observations, apart from the minimum, maximum or extreme values in your data set, you have the results which pertains to the dispersion, the spread of your data set along with this central tendency. So instead of using this default summary function, you can use stat.desc. So very quickly, now in order to perform or fit the simple regression model on my data set, which is known as pine, I will use this function fit followed by this assignment operator and a default function. I will simply put my cursor here and I will click on this run option. Then the traditional way of getting the estimates of our coefficients, I can say the estimates of my intercept and my regression coefficient, both of them are significant, and we have a good value of coefficient of determination, almost 90%, and the fitted model is found out to be significant. But we are more interested to test the assumptions of this fitted model. That is, we can simply write this default function view followed by this default function nice underscore assumptions and followed by the name of the fitted model. So if we will highlight this and click on this run option, so we can see the diagnostic value here is 2, since two of the important assumptions regarding the errors of this fitted model, that is, the first one is whether our errors are normally distributed, whether there is an existence of homogeneity of variance, whether the errors are independently, whether there is an existence of correlation, or whether there is a presence of correlation between the successive error terms. So by this way we can test the basic assumptions of our fitted regression model. So in order to proceed, we'll be using another data set in order to fit a multiple linear regression. For that I have a data set which is already imported on my R console. It has got 1, 2, 3 and 4 variables. This fourth variable yield is my response or study variable, or you can say the dependent variable, and rest of the 3 are explanatory variables. So first, before proceeding multiple regression analysis, we always are interested, we are always, as a researcher, the correlation among the variables is very important. So in order to test whether there is an existence of correlation among the variables, on which we are performing the multiple linear regression. So we'll be performing the correlation analysis by means of by portraying a plot of correlation, or we can say portraying a correlation plot utilizing library metan. For that, we'll run on this. We will click on run option here. Then the names of my data set is this: year, length, weight, and yield is my response variable. Then I'll be using this function, and I will click on this run. Then I will use a default function plot. Since this cor underscore c of it calculates the correlation coefficients among the variables, and plot is a default function. If we will click on this, we'll highlight this, then click on this run option. We'll have a plot here, correlation plot, where we can find out there is a positive correlation between yield and years, and it is significant, and there is a non-significant correlation, although it's negative, but it is a non-significant correlation between yield and weight. Similarly, we can give, or we can interpret the result of the rest of the pairs. Now, since we have a multiple regression model, and in case of multiple regression models we have a problem of multicollinearities whenever there's a huge amount of correlation that exists between the variables, especially the explanatory variables. Although in this example there is a less amount of correlation among the explanatory variables, but still, for the sake of presence and for the sake of making you understand how this multicollinearity can be detected utilizing this RStudio. Since multicollinearity is present, there are two criteria for that. One is variance inflation factor, and another one are condition indices. If the variance inflation factor is between the range of 5 to 10, or we can say greater than 5, or the indices are higher than 10 to 30, we assume that there's a presence of multicollinearity present in that data. And if it is 1, there is no, and if it is between 1 and 5, we say it's a moderate amount of multicollinearity. And the variance, if the variance inflation factor is greater than 5, then we can say it's a severe amount of correlation. So in order to perform the multiple regression analysis on this data set, which is known as MLR, where yield is dependent variable, for that we can name the function as fit, or we can write the name of a function followed by assignment operator, or is equal to, again we'll write lm, which is a default name or function here, followed by the name of response variable, followed by tilde sign. And we don't need to write all the explanatory variables one by one. Rather than, we'll use a shortcut here, dot comma data is equal to MLR. Then we'll click on this enter. Okay, then again we will use a default function summary, then fit. Then we will click on this fit. Okay, we have the results for our rest of the variables, or we have a results for our fitted multiple regression models. We have the results for, or the estimates for our intercept with the partial regression coefficient. For year it is 2.0, and for length it is minus 0.2. For weight it is this, and we have a very good amount of R square here, that is 0.74. So the 74% of the variation in yield is explained by all these variables. So in order to see whether there is an existence of multicollinearity or not, we will simply write VIF fit and click on this run option. So since you can see the VIF for years, length and weight is almost equal to 1, so there is a very weak amount of multicollinearity or correlation that exists in this data set. Apart from this multiple linear regression, we have an extension of this multiple regression analysis that is known as path coefficient analysis, which is usually used in plant breeding experiments. and the breeders are very interested to separate the direct and indirect effects through the attributes of partitioning the correlations. So we can say it's a standardized version of the regression analysis. So in order to perform the path coefficient for our data set, which we have used in case of multiple linear regression, we have to write a function which is a default function, path underscore coef, okay, then followed by the name of the data set, which is MLR, then followed by the name of the response variable, which is yield in this example. Then we have to write the name of variables, of explanatory variables, rather we can say the predictors, in the form of a vector by using this small c, which is known as a concatenation function. Then within this brackets we have to write the names of the independent variables like weight, length, and all this. Then simply we have to press the enter button, and there is a problem in this. We have a error message here, and because R is case sensitive, because here we have spelled it like this, so we'll click again on this, LENGTH. Here we go. So the error message which got popped up here, it is because due to this, because R is case sensitive, and we have to be very cautious about these kind of things. If we have written something in capitals, we have to write in capital. If we have written something and we will not write the exact term for that, then we will always find out these kind of errors. So here the indication is that the weak multicollinearity, since the condition number is very low, 2.1, and we have a correlation matrix where we can find out what kind of correlation or what kind of linear relationship exists between the variables. Then we have a vector of correlation between a dependent variable and each of the predictor. Then again we have a multicollinearity diagnosis and the goodness of fit here. Then variance inflation factors also here. Then the final one, which is very important, table for direct and indirect effects. This 0.085, it is the direct effect of errors on our response variable, which is yield, and this minus 0.00173, it is the indirect effect of this variable errors on the response variable, which is yield, via this length. Similarly, we can interpret the others. If we will see, if we will sum up all these direct and indirect effects, it's equal to the overall correlation. Like if we will take this plus this plus this and we make a factor of this, like in this way, we'll click on this run option, we'll find the sum will always be equal to this. The sum, like we have a vector, we'll write sum, in within this bracket we'll write this, so it is 0.85. So it is a clear indication that this path analysis actually breaks down the overall correlation into direct and indirect effects. Hope this video will be quite beneficial for the people who are watching this, for the researchers who are watching this. Thank you very much.